Next question is, what is convergence theory in machine learning and its formula? Again, formula is something that we can always remember later, but we should understand the concept more clearly on this. As convergence theory is one of the most important content that we need to know when you're discussing gradient descent and linear regression. Now, what is convergence? Basically, when we talk about gradient descent curve and we are getting to the point, like in the last part I have discussed at the end, that we are trying to reach to the global minima, and that global minima is the point where we declare that this is my best fit line position. Now, to reach to this global minima is called converge. We converge towards the global minima. This particular converge terminology is basically means that we're converging towards the global minima part. Okay, now what is convergence theory? That means we are discussing how the value of m, I again repeat, how the value of m get modified in what? Get modified in y equals to mx plus c. We have this equation, and how it get modified in that equation, that is what it is all about. So we have y equals to mx plus c, and we want to know that how the value of m in this case is getting modified. So what happened? We simply subtract the value of m with the old m that we have. So we have the old m, say I call it m0. So m0 is subtracted from the new m, and that is what is going to give you the latest update. So let's not discuss it like this. Let's think about it as like theta is there. The theta is the old m that we want to have. So m new, if we talk about I'm saying it capital so it's easy to read. So I'm new, or say I'm new, so I'm giving a dash over it, okay, is equals to the old m that I used to have, and I subtract it with the lambda, the learning rate. So I'm saying it as L, and I'm multiplying this lambda, the learning rate, with the derivative. So with the derivative I mean the derivative of m with the derivative of y minus y, means that is y dash minus y, and we will be seeing the loss function that we have. So basically the loss function that we had, the derivative, and we subtract, divide it, and we have the derivative of the old m. So derivative of the old m with respect to derivative of the loss. Basically, it will be said as m minus lambda derivative of loss divided by derivative of the old m, same m. Okay, that will, this particular formula will give you the new value of m. Now, when I say new value of m, another way of saying it is at the left side, theta equals to theta j equals to theta minus lambda derivative of j, theta 0, theta 1, that is the loss function that we are calculating, divided by the derivative of the theta, the old m that we already have. And this will give you the new value of m. Now, this lambda is something that plays a very important role in the convergence theory. When I say it converges, as I already told you, it means it is reaching towards the mean position, the global minimum position. Now, to reach this particular point, to reach this global minimum position, it start moving from this position, right? And it keep moving and it keep moving till it reach this point. But one thing that we need to understand, that it is reaching toward the global minima. Now guys, when we are reaching towards the global minima point, the m value keep changing too, because the line that we have, the best fit position that we will be reaching, all this plays a role in this particular convergence part. So new value of m comes to the picture. This y that we have is going to update the m value, then we calculate the new value. Intercept may also change at the as per the requirement, and the convergence start happening. This will take little time, and it will reach to the point where the error, the loss function is minimum. Now, this step that I'm talking about, the particular step that we have taken, that depends on the lambda. So this lambda that we have here, or this lambda that we have here, plays an important role with the steps that we have. Okay, so every jump, every step is going to be a result of this lambda only. Now, we need to understand that we are moving towards this point, and this conversion that is happening, it will be happening as the value of m gets modified and as the complete equation gets modified because of this m change. And this particular m is the result of this lambda and the derivative multiplication. If the lambda value is small, the steps will be small. If the lambda value is big, the steps that it is taking is going to be big. So in the convergence, in the curve, the steps that it is going to take is going to be big and small according to the requirement, according to the lambda. So if I take this lambda very small, the steps will be very small too. That means it will take forever to reach the global minima position. We don't want that. And that is the very reason that we want to take big step. But if I take big step, suppose I literally go for big step, there's a good chance that we jump over it and then we again come back, then we again jump over it, we again come back, and we keep doing this. And we never reach to the global minima, which is again bigger problem. So what we do, we find a basic solution on this. We make the initial step bigger, and as we keep reaching to the global minima point, we make the steps smaller. Now how it realize that it is reaching to the global minima? So as we are reaching this point, guys, it is not a correct diagram. Basically, you should be having a correct line in center. Okay, most of the time you see this diagram only or this diagram only, but say think the line is at the center and it is trying to reach to the global minima. So basically, when it takes the bigger step initially, it is trying to come closer to the zero. Okay, so we have this curve, we have this line, we have zero at this position. Okay, and the line is this. Okay, so this particular point is coming down. This intercept is getting reduced and reduced, and we are getting closer to the minima. This is mean square error. This line indicates mean square error, a negative point and this positive point. So wherever it is coming, it may come from the negative or positive, and it is trying to reach to this global minima. And when it is reaching to the global minima, the more closer it gets to the zero, or you can say more less the difference is there in the error. Now what do I mean by that? So you are calculating the mean square error with every step. Suppose initially it was 10, then when we move low it got 9, then it got 8, then it got 7. All of a sudden after 7 it is moving like this, 6.9. Okay, then it is moving 6.85. So it indicates that the error change is getting smaller. That means line is closer to the points that we have. Which line? That line we are drawing. Okay, so this particular line that we used to have, we always have the diagram. This line is getting closer to the points that we want to we want to reduce the error with. So let me make it these points. So we have these points. Okay, and this line is getting closer and closer. That means this line is moving from this position and it is reaching. So first when the error was 10, then it moves and it got 9, then 7, then 6, then all of us, sorry, 7, then 6.9, then 6.5, then 6.4. So it indicates that we are getting really close to the error. And as the line is getting closer, it is reaching more closer to the zero. It is reaching more closer to the zero. So the error value is reducing a big number, then error value is reduced to a smaller number, plus it is reaching closer to the zero. Both these positions indicate that we are about to reach the global minimum position. That indicates to the model that we should start reducing the lambda value, and it start reducing the lambda value, and slowly it converge towards the global minimum position. And that is how it works. So when you're explaining this, if you can explain the 20% of this, that is more than enough. You should understand the global minima convergence part. You should understand what is on the axis. So what is on the y and the x-axis. So intercept and the mean square error is on the axis. And these star are plotted between the independent and the dependent variables. So independent, dependent variable plot the stars, and this intercept and the mean square error can plot this line. And it starts from a random position. It goes closer to the point as the error reduces, and the goal is to have the least amount of error. Okay, that is called the best fit position for the line. That is all for convergence theory. I hope it makes sense. and make it as simple as possible to understand. That will be the easiest way. And let me clean all those things. If question is asked, what is convergence theory in machine learning, you will say it is a method through which the model converges to the best fit line position by keeping the dependent values as data points, and by moving the line which is between the intercept and the mean square error, moving towards the global minimum position where the error is least. Formula for convergence: m minus lambda into derivative of loss divided by derivative of olam, same am basically. This formula updates the value of am and it is put it in the y equals to mx plus c. This am value get changes, the whole equation get changes, the coefficient get changes, and then we have the new values. This is how it really works. I hope you can link all the details clearly now and the dots are connected for you. So that will be all for convergence theory.